I'm going to do some examples of balanced forces and drawing their free body diagrams. So while we do this, we're going to develop a few equations we haven't seen as well, just to do them while we go along. So in this first case, it's important to realize balanced forces means the acceleration and thus the net force are zero. And they're balanced forces for a reason. They are balanced. So our first one says I have a book sitting on a desk. Now, of course, this is what it would look like in real life. But when we go to draw what's called a free body diagram, that is your book right there. There's your book. You're not drawing its actual body. That's the free body part. And then what I need to do is think of what forces are acting on this. What forces act on this book? And the first one that is most obvious is the fact this contraption is on the earth, right? We assume we're on the earth, and that means gravity is pulling it downwards. So I'm going to draw that as a downwards arrow. Mine was not terribly straight, but that's okay. So downwards arrow, and I'm going to label it, F for force, and then what's called a subscript, a small g, the force of gravity. Now, counteracting the force of gravity is the fact that this book is not falling. By this free body diagram, if I left it like this, it would look like the book was falling, and it's not. What's holding it up? The table. The table is holding it up. And this is actually an example of Newton's third law, the action and reaction force. So the action and reaction force is important. It shows the action of the force of gravity. The reaction is this upwards force of the table supporting it. These two are going to be equal or balanced, the same size. And it needs a name. Now this might seem like a strange name to you, but we call this, it's a force, and we call it the normal force. Again, the N is a subscript. The normal force we call it a normal force because it's 90 degrees to the surface, because if you think about the surface, it is straight up or 90 degrees to the surface. And that's a math term, the normal. So I'm just going to quickly just define these down here, that Fn, we're talking about the normal force, and Fg, we're talking about the force of gravity. So this is the gravity force. So those are important to realize. Now, up until now, we've only talked about gravity by itself, and we've talked about it as acceleration due to gravity. It's important to realize these are balanced. So that means that in this case, Fg is equal to Fn. And this is actually going to be really true throughout this particular course. Once we get into grade 12 and we start looking at forces on angles, or if you go on to college, you'll talk about forces on angles, then they're not necessarily equal. But this year, they will be equal. Which means if I can calculate one, I know the other. And the important thing about the force of gravity is we can take an adjusted version of Newton's second law. Newton's second law is that the net force is the mass times the acceleration. Gravity is the mass times the acceleration due to gravity. And on Earth, of course, we know it's 9.8 and always will be. This will give us a numerical value for our gravity force, which at the same time tells us our normal force.